So here we are provided that log of x divided by b minus c equals log of y divided by c minus a and log of z divided by a minus b. Here x, y and z are all positive numbers and a, b and c are not equals to 1. Using these facts, we need to find out the value of this particular expression. So let's begin. So we will start with whatever is provided to us. We are given that log of x divided by b minus c, that's equals to log of y divided by c minus a, and that's equals to log of z divided by a minus b. Let's say this is equals to some constant lambda. Now, what we'll do, we'll begin with the first one. So let's say we have log of x divided by b minus c, and that let's take it to be equals to lambda. Now we'll cross multiply to get log of x equals to lambda times b minus c. Now what we'll do, see, in our expression we have x raised to the power of b plus c minus a. Now in order to reach here, first we'll begin by multiplying both sides with b plus c minus a times log of x. Similarly, we multiply it to the right hand side as well. So we have b minus c multiplied to b plus c minus a. In doing so, what we can do here, we will use a property of logarithm and rewrite the term on the left hand side as log of x raised to the power of b plus c minus a. So here what we have done, we have used the property of logarithm. That means if we have a times log of b, that this is the same as log of b raised to the power of a. So this is a property of logarithm. This will be equals to lambda time. So what we'll do, we'll multiply b minus c with b plus c minus a. So this is going to give us b squared minus c squared plus ca minus ab. So let's label this as equation number 1. Then we'll consider log of y divided by c minus a will equals to lambda times, it's lambda. So that means log of y will be equals to lambda times c minus a. We'll multiply both sides with the exponent of y, which is c plus a minus b multiplied to log of y. So that will be equals to lambda times c minus a multiplied to c plus a minus b, or we can say log of y raised to the power of c plus a minus b. So that will be equals to lambda times, so we'll multiply c minus a with c plus a minus b, which will give us c squared minus a squared plus ab minus bc. Then we will consider the third expression, which is we'll call it equation number 2. So we'll take log of z divided by a minus b, and this will be equals to lambda, such that we have log of z equals to lambda times a minus b, and we'll multiply both sides with a plus b minus c. Multiply to log of z equals to lambda times a minus b multiplied to a plus b minus c, which gives us log of z raised to the power of a plus b minus c equals to lambda times a squared minus b squared plus bc minus ca. And let's label this as equation number 3. So what we'll do, we'll add 1, 2 and 3 together. So adding 1, 2 and 3, so this is going to give us log of x raised to the power of b plus c minus a plus log of y raised to the power of c plus a minus b plus log of z raised to the power of a plus b minus c equals to, we'll add all the terms on the right hand side. So we have lambda as a common factor, so we'll take lambda common. So this is multiplied to b squared minus c squared plus ca minus ab plus c squared minus a squared plus ab minus bc plus a squared minus b squared plus bc minus ca. So that means, let's see which gets cancelled out. So we have positive b squared, negative c squared, positive c squared, and negative a squared, positive a squared. We have plus CA minus AB plus AB minus BC plus B. That means everything got cancelled out. Our right hand side will be equals to 0. Now what we can do, we can combine the three terms on the left hand side using a property of logarithm. That means if we have log of A added to log of B, so that's the same as log of A times B. So let's use this property. We will get log of x raised to the power of B plus C minus A times y raised to the power of C plus A minus B times z raised to the power of A plus B minus C. And on the right hand side, since everything got cancelled out, so we have lambda times 0, which will be 0. Now what we will do, we'll use a definition of logarithm. Our definition of logarithm is if we have log of A with a base B, and if this value is equals to C, then that means we have A equals to B raised to the power of C. Now in a case, the base of the logarithm is not provided, and whenever it's not provided, by default we assume it to be equals to 10. So that means now if we use the definition of logarithm, we'll have on the left hand side x raised to the power of B plus C minus A multiplied to y raised to the power of C plus A minus B times z raised to the power of A plus B minus C. That will be equals to 10 raised to the power of 0. And we know that 10 raised to the power of 0 is going to be equals to 1. So this is going to be the final value of a given expression, which is 1.